Hello, everyone. Welcome to another session in Hort Americas TV. Today, we will explore a little bit further the interpretation of data inside of growing systems. Many times, growers experience the curiosity to know what is going on inside of their growing systems when variables get out of control. As we always mention in our videos, the more you measure, the better control you have over your system. However, this will only apply when we know how to interpret data. Otherwise, we will have just a bunch of numbers. So let's learn a little about data interpretation and the interaction between different CEA variables. For example, CO2 and photosynthesis, light and photosynthesis, vapor pressure deficit and transpiration, and temperature and metabolism. There are a lot of environmental variables that we can manage inside of growing systems, but for this video, we will focus on these ones. So let's start with CO2 and photosynthesis. CO2 enrichment is commonly used in plant factories and also in some greenhouses. However, we must understand more CO2 will not mean higher photosynthesis all the time. There is a saturation point for all crops, and usually this response is crop specific. If you go way higher to the saturation point for your crop, stomata will close and photosynthesis will start to go down. So it's really important to pay attention to the crop requirements and only use the requirements of CO2 that you know are good for your plant. For most plants, the saturation point is between 1000 or 1500 ppm. But now let's put light into this scenario. There is evidence showing that more light in a system with higher CO2 concentration can promote more photosynthesis than using the same amount of light in an ambient with less CO2 concentration. This is why CO2 injection is useful inside of plant factories, where the sole source of light is artificial, and we need to keep the use of light very efficient. So in this kind of system, if you have higher CO2 levels, if you reach the saturation point and you have good light intensity, you can probably push photosynthesis a little bit more than in the same situation, but with lower CO2 levels. By increasing CO2 in growing system to the optimal level for our crop, we can increase yield. But now you also know the importance of light in this equation. Now let's move to VPD and transpiration. Remember, VPD is vapor pressure deficit. And this is a tricky one because transpiration is good for plants. It helps to take up water and some nutrients. However, in excess can also be problematic. It can change the way the plant is taking up water and nutrients. It can cause even nutrient deficiencies. And humidity is also very similar because we want humidity in our system, but just enough to keep our plants healthy. So let's start explaining a little bit about transpiration and the impact of transpiration inside of the greenhouse or a plant factory. Transpiration converts energy in latent heat, and latent heat mitigates the warming up in the greenhouse. So this is an effect of transpiration in temperature inside of growing systems. Now, humidity can also affect temperature and can also affect transpiration. Actually, relative humidity determines transpiration. We know higher VPD levels increase transpiration, and higher VPD levels are usually related to low humidity levels in the air. Remember, humidity requirements are crop specific. High and low humidity levels can affect the crop health. So it's always important to check the requirements for your crop and to pay attention to all the variables that can also affect the transpiration. VPD is calculated based on relative humidity and temperature. meaning that temperature can also affect transpiration and of course also crop development. So how temperature relates now to the development of the plant, that we can also call this the plant metabolism. In greenhouses, it's important always to know our crop. We always want to be able to predict harvest time. For this, we need to understand the variables that we have inside of the greenhouse that can affect harvest time. Metabolism is one of them. The lower the temperature, the lower metabolism, which can affect plant development and harvest time. On the other hand, higher temperature can accelerate plant metabolism. Some of us probably think this is a good thing if the plant is accelerated, but it's not. For example, if we have higher metabolism, the plant will start to grow more quickly. Probably we will have more development, we will have more flowers, but the plant have the same energy. It's the same energy, it's only that the plant is working more because it's accelerated. So if the plant is making more flowers, those flowers will be smaller. Smaller flowers is equal to small fruits. So now we can learn that high temperature and the acceleration of the metabolism can have a huge impact in the product quality. Also, if the plant is accelerated, some nutrients sometimes cannot be taken up in the correct time, and new leaves can start to show some deficiencies. This is common for passive nutrients, and it can happen because of the temperature and also when we have a lot of light. Now you can get an idea of the relation between different environmental variables. You know, our quote, the more you measure, the better control you have over your system. But it's really important to check and understand all the variables that you can check inside of your greenhouse. I hope you enjoyed this session. We will continue studying the relation between different variables. Please subscribe if you like this video and leave comments and questions. And if you are interested in a different variable, please just go here below in your comment, and we will try to keep working in this topic. Remember, my name is Carla Garcia, Hort Americas Technical Service. You can find me also as Professor Grow in Instagram. So that's it for today. Bye-bye.